Okay, in this video we're going to look at what are called arithmetic series. And another name for a series is what we call a partial sum. So what we're looking at here is not what are the terms of an arithmetic sequence, but what do I get if I add those things together, if I add those terms together. So first of all, I have to know that my sequence is arithmetic, which means that we have a common difference, that we are adding or subtracting the same number every time to get from one term to the next. If I have that kind of sequence, then I can find the sum of the first n number of terms of that sequence by using one of these two formulas. And again, that's going to be called our partial sum, or we may refer to that as a series. So I've got two different formulas here for that. One is if I have the common difference. Okay, so if you have the common difference, you want to use this first formula. The second one would be if I know the value of the last term of your sequence, then I can use that second formula. So both formulas require that you know n, which is the number of terms that you want to add together. A is the first term of your sequence. Both of those require both n and a. Okay, so that's again the first term of the sequence and the number of terms that you want to add together. The first formula requires you know the common difference. The second formula requires you know the value of the last term, the value of the nth term. All right, find the sum of the first 40 terms of the arithmetic sequence. So again, I know that this is an arithmetic sequence. I can see that I'm simply just adding 4 to get from one term to the next. So it is arithmetic. And I want to add together the first 40 terms of this. Now, if I didn't have this formula, I would have to figure out what the 40 terms are, the first 40 terms are, and then I would need to sit there and add all those together, which would take a lot of time to do. So instead, I can use my formula. So we're going to find the sum of the first 40 terms. Now, what I know is I know the common difference is 4. So since I know the common difference, I'm going to use this first formula. I don't know the value of the last term. Like, I don't know the 40th term of this sequence. So I can't use this second formula. We use the first one. We have n divided by 2, so that's the number of terms that I want to add together, divided by 2. And I'm going to multiply that by 2 times a. A is the first term, which is 3, plus n minus 1, so that's the number of terms that I want to add together, minus 1, times the common difference, which we know is 4. And I have, at that point in time, just some computation that I would need to work through to figure that out. Which you can use a calculator for. We get 3,240 if we work through that. Okay, so that tells me if I continued this out for the first 40 terms of the sequence, and then I added all of those numbers together, this is the value that I would get. Number 2, find the sum of the first 50 odd numbers. The first 50 odd numbers. You could use either formula for this if you knew what the 50th odd number was. You may have to think about that a little bit to figure out what that would be. You could use the first formula if you know what the common difference is. So what is the difference between one odd number and the next odd number? I think that you would probably understand that a little bit more. Some of you may know what the 50th odd number is, and in that case I would say, well, go ahead and use this formula. It's a little bit easier actually if you do know that. But I'm going to use the first formula. I'm going to find the sum of the first 50 odd numbers. So n is 50. I'm going to add together 50 numbers. A is the first odd number. That would be 1, plus n minus 1, so that's 50 minus 1, times d, our common difference. Well, what is the difference between odd numbers? That would be 2, right? So 1 to 3 to 5 to 7. My common difference is 2. I add all that, multiply, I end up with 2,500. Number 3, an amphitheater has 50 rows of seats. 30 seats in the first row, 32 in the second, 34 in the third, and so on. So I can follow that pattern knowing that it is arithmetic, that we are getting 2 more seats for each consecutive row. I want to find the total number of seats in this amphitheater. So what am I adding together? Well, I'm adding together the seats in each row. So how many rows am I adding together? I'm adding together 50 rows. So this is going to be S50 again. Again, we're going to use 50 for n, so 50 divided by 2. The first row has 30, so that's my A value. Again, n is 50. And the common difference is the difference between the number of seats in each consecutive row, which is 2. And we can evaluate that and we get 3,950. So that's the total number of seats in the amphitheater. Okay, last one is a little bit tricky here. So we want to find the number of terms in this partial sum. So I know the value of the sum, right? So I've got a sequence that starts 5, 7, 9. I know it's arithmetic, it tells me that. So my common difference is 2. How many of those must be added to get 572? So I want my sum to be this value. How many of these terms do I need to add together? So if we think about our formula, we actually know S of n. S of n is my sum of the first n terms. That's 572. I know A. A is my first term, which is 5. I know the common difference D. That is 2. What I don't know is how many terms there are. So that is what I have to find. So if I use this formula, I know that the value is 572. I get that when I take some number of terms divided by 2 times twice A, so that's 2 times 5, plus n minus 1 times my common difference of 2. And what I'm going to have to do is I'm going to have to work this out and solve for n. So it's going to take a few steps here to get there. So 572 is equal to n divided by 2. On the inside here we would have 10 plus, if I distribute my 2 here, I'm going to get 2n minus 2. Okay, so that's 572 is equal to n over 2 times 2n plus 8. If I combine the negative 2 and the 10 together. What I'm going to do at that point is I'm going to distribute this n over 2. So I'm distributing a 1/2 n here. So I'm going to get 572 is equal to, well, if I take n over 2 times 2n, my 2's are going to cancel out. I'm just going to get n squared for that term. Plus 1/2 n times 8 would be 4n. Now I hope that you see we have a quadratic. So what I'm going to do is subtract the 572. So I'm going to have n squared plus 4n minus 572 equals 0. You shouldn't need to use the quadratic formula. You could, but you should think, hey, I'm trying to find n. N is the number of terms I need to add together. N is going to be a whole number, right? It's not going to be some weird number that I'm going to get from the quadratic formula where I have like an irrational number. That's not going to make sense, right? So I should be able to factor this. So I need to think about what would multiply to negative 572 and add to positive 4. And that's going to be positive 26 and negative 22. So if I set those equal to 0, I get that n equals negative 26 and n equals positive 22. Well, those would be the solutions to that quadratic, yes. But what makes sense here? We're looking for the number of terms of a sequence, so a negative value does not make sense. So that tells me that we have to add together the first 22 terms of this sequence in order to get a sum of 572.